Hello, so this is another confidence interval question with the central limit theorem. The central limit theorem is not mentioned, but the fact that it doesn't say anything about the normal distribution, and we're going to be using it because the sample size is 100, which is why I've mentioned central limit theorem in the title. But that's the last I will mention of it. It's a confidence interval question, and we can use the normal distribution because of the central limit theorem. Okay, I've got a few issues with part A. This isn't a past exam question. It was from the Heinemann S3 textbook for edexcel. So yeah, I've got a few issues with it because, of course, if we wanted different confidence limits, we would need a different size sample, which is actually what the question is leading to, which might then, of course, not lead to unlikely to lead to the same midpoint of the same mean, because randomly the means will be different, won't they? But anyway, we have to take the question on face value. So it says we want a confidence interval of width £10. We can see the middle of the original sample that we had is going to be halfway between those is 135. So that's the middle of our confidence interval. So we're going 5 each side. So the confidence interval needs to be 5 each side of 135. So that's going to be 130 to 140. Okay, so I've got a few issues with it because it's a bit strange, really. But anyway, we've got to take it. It's the only answer that we can give to that question. Part B, basically, we've got to use the fact that we have been told that there's a 95% confidence interval for between the two values here, 128.14 and 141.86, with the middle being 135, that this is a 95% confidence interval. And then we've got to use that fact to find what percentage we would have between between 130 and 140. It's obviously going to be less because it's a narrower interval. So we're trying to find that. Now the thing is, we're not told what the standard deviation of the original distribution is. At this point, it's probably good to talk about the standard error of the sampling distribution, and we're not given the standard deviation of the original distribution. So the variance of the sampling distribution is that. So the standard error is equal to sigma over 10, the standard deviation of the original distribution divided by 10. Right, what I'm going to do is compare it to the Z distribution. I kind of scale it. They're obviously not the same scale, but if I kind of draw the Z distribution below, such that we have 90, I can easily get this number here as 1.96. and this number here is minus 1.96. Again, we can either use the tables or the calculator to get that number. I'll just show the calculator once. So menu 7, normal CD, and we're putting 0.975 into there because it's 2.5% each side. So we get 0.9, it's actually very close to 1.96, so we'll leave it as 1.96. Now here it's probably best not to overcomplicate this. We know that the standard deviation of the standard normal distribution is 1. So we can compare that with the standard error of this distribution, which is sigma over 10. We can compare that with that number. So the distance from here to here must be scaled similarly to the standard normal distribution here. The standard deviation of a standard normal distribution is 1, but to get to 95% or 0.975, we need to go 1.96. So therefore the length of this interval from here to here must be 1.96 times by the standard error. So that gives us 1.96 times by sigma over 10, that's the standard error, is equal to whatever the length of that interval is, which is 141.86 minus 135. That gives us a standard error, the standard deviation of the sampling distribution, which is sigma over 10 of the original distribution, is equal to 3.5. Standard deviation, therefore, sigma is equal to 35. But I'm just writing both down so that we don't get confused between the two. Because we're back to this again. This is our sampling distribution, remember, not the original distribution. We want, for the sample, we want to know what the percentage would be between 130 and 140. What's the chance, what confidence level have we got that, given the sample that we've got, that it'll be between 130 and 140? And we can use the calculator again now, but remember, it starts with the sampling distribution. The mean of this particular sample is 135, and the standard error is 3.5. So we're going to put those numbers into a calculator to work out the percentage. Okay, so menu 7, and we want normal CD again, so that's 2. The lower tail we want to be 130. The upper tail we want to be 140. The standard deviation, which is the standard error of our sampling distribution, is 3.5. And our mean is 135. So that's 0.847. Apologies, I just noticed I've written 35 there. It's obviously 135. Hopefully you picked that up. So we've got the probability that mu lies between 130 and 140 from the calculator is equal to 84.7%. That's our level of confidence. It will lie between those two from the original sample of 100. Okay, let's bring the question back down again for the final part. And now we want to know what sample size would be needed to actually get the 95% confidence interval to be between 130 and 140. Okay, so now let's bring down the standard normal distribution that we had from before. Okay, let's bring that down, and we're going to use that again. We know one of the reasons I distinguish between standard error and standard deviation. The new standard error now will be sigma over the square root of n, which is equal to 35 over the square root of n, because it's the original standard deviation of the actual parent distribution divided by the square root of n is our standard error. Right, so now we want to have, again, we want it so that 95% lies between these two values, 140 and 130. So again, this is 1.9, we need this 1.96 times by the standard error, because we're comparing with the original standard normal distribution. We want that length to be 1.96 times by the standard error to work it out. So we can therefore work that out, because the length is obviously 5. So you have 1.96 times by 35 over the square root of n is equal to 5. So that gives us a square root of n is equal to 1.96 times 7, which is equal to 13.72. So therefore we have n equals to the square of 13.72, which is equal to 188.2. So we need n to be bigger than this, need to be more than that. So n, smallest n, for a confidence interval of 95% is equal to, or less, is equal to 189. Okay. I do find, you may, apologies for those who've learned a different way, I do like to quote standard results. I do like to try and feel my way into these questions using the standard normal distribution with basic principles like that's the standard error, rather than memorizing results. I just always like to go back to scratch. That's it. I hope you found it useful. Bye.